Thank you for watching this presentation. This is part 2 of an introduction to my book, I Have Become Space, by myself, Douglas W. Lipp. A prerequisite to part 2, which is the cosmological part of my theory, the Coney Island green theory. A prerequisite is part 1. So you should really read, or rather watch, part 1 as a prerequisite to this part 2. I do want to back up because on the quantum classical world, there were 2 items I thought might be of value to some people, maybe not. If not, completely ignore it. One is the neutrino problem. The neutrino problem, per CIG theory, suggests that the oscillation of neutrino masses of group 1, group 2, and group 3 are based on, again, MTS. So those fine variations between the electron neutrino, the muon neutrino, and the tau neutrino are variations on their rate of travel within the MTS equation. Recall that everything happens within the MTS equation. So I'm throwing it out there as also a solution to the neutrino mass problem. I'm also looking at the concept of time dilation as I understand it, which probably is not in great depth, because again, I haven't taken the courses, but I've tried to learn the concept as best I can. And I've reinterpreted time dilation as the creation of new space. So if you recall, through relativity, time dilation presents itself with rates of travel. Within the T, you have rates of travel. But instead of different times being imparted on the world universe, I'm stating that there's different volumes being imparted on the world universe. As an example to maybe substantiate that view, I'm looking at, say, a child walking out of an ice cream store with a nice triple layer ice cream, all the sprinkles, rainbow. Let's go with rainbow. And within that child, there's motion. There's different motions. There's the molecular motions, the motions of the protons, of the quarks, of the gluons, motion of the girl actually leaving the ice cream store herself. And there are so many multitudes of time dilations going on that I'm looking at new volumes as bringing a cohesiveness to any body that's in motion, in our case, the young child with an ice cream cone. So as that child leaves the ice cream store, that child leaves there intact, bringing everything along with him or her, including the ice cream cone, and avoids the complications of time dilations where there'd be so many multitudes of times that she might be leaving part of her inside the ice cream store as she's leaving. Now, maybe I don't understand time dilation well enough, but what I'm attempting to say here is that the new volumes of space bring a cohesiveness to moving bodies so that everything can exist in the same time. So when I look at a room now, I see that everything is everything else, including the volumes, the matter, the motions. It's all within the one equation. So I just wanted to back into the quantum classical world because those 2 points I didn't make in part 1 But we're now in part 2, the cosmological section. So very briefly, black holes, the M side of the equation. It's a singularity. There's no motion. Obviously, we're going to discount the horizon effects. We're going to look at the curvatures of a black hole as the well in space-time. And wherever you look at, from whatever direction, that well is going to exist. So you're only going to see, looking down at any section, you're only going to see that disk with no dimension in its singularity, just a flat disk. Now maybe that's why, again, this part is not in the book, maybe that's why the surface area gets larger of a black hole and not the volume, because you only have surface area from whatever direction you're looking at. You're only looking into a well, and you're looking into a well every which way and seeing the same thing. So there is no volume. All there is that disk. And when something else falls into it, it's the surface area that gets bigger, not the volume. Maybe I'm wrong on that. It was just some thinking I've done recently as regards black holes and the concept of holograms, the holograms. Not too sure about that, but it was worth mentioning. Okay, we're going to move from black holes to dark matter. Now, before I mention dark matter, we've got different numbers here. And these are Googled numbers, and I don't quite know how they came up with them. I don't quite know how they came up with most of this stuff, but 4.9% represents matter. 26.8% dark matter, 68.3% dark energy. So the dark matter, my blue, I found my blue. The dark matter is, back in the day, Fritz Zwicky and Vera Rubin, and they are looking at the velocities of galaxies and stars, and what they're finding is that on the outside of galaxies, that these stars are moving so fast that they should be flying off, but they're not flying off. So from the viewpoint of physics, they had to rationalize that to keep them gravitationally inbound to the galaxy, that there has to be another element. That element is called dark matter. It's that dark matter that holds the galaxy together. In CIG theory, that dark matter represents a spatial quantity with a spatial density not quite as tight as the core of the galaxy, not quite completely outer space, which is the dark energy, we'll get there next, but is somewhere in between. They're seeing halos. And these halos represent the dark matter, which keeps the stellar entities gravitationally inbound so they're not flying off. So in SIG theory, it interprets this dark matter as something within the MTS equation, not quite full space, certainly not matter, but somewhere in between. So that's the dark matter. This 68.3% is dark energy. Now, dark energy, as far as I know, and might be wrong, but historically, you had Vesto Slipher with, I believe it wasn't quite type 1a supernovas, but standard candles, and then Edwin Hubble observed that there was a redshift to the light. And a redshift to the light is like the Doppler effect, or the sound you're hearing when a train moves away from you. When a train moves towards you, the waves get very condensed, and there's a certain, I guess, low pitch, and then as that train goes away, the pitch gets higher and higher. Well, they observed the red end of the spectrum, Roy G. Biv, the light spectrum, and they found that it was shifted away, which means it is moving away from you, the red light. Actually, the light's coming towards you, but they're seeing that the light you're receiving here on Earth, instead of it having a wavelength like this, the wavelength is now shifted. And that's redshift, which was very crucial to the concept that things are moving away. But that's always been interpreted that what's moving away is this galaxy from this galaxy from this galaxy, such that this galaxy might be here, this one here, and this one over here. And the space between them is the dark energy. And that dark energy, remember this is their theory, or current theory as I understand it, that dark energy came from the space itself. It came from this point. What SIG theory says, it breaks away from that. And it says that the space came from the matter. That this matter unfolded to create this new space. And a crucial part of this is that is conservation of energy. Their notion that all this space was created because things are moving away from each other at no expense other than space unfolds by itself is not consistent with conservation of energy. So SIG is consistent with conservation of energy. So this is dark energy. It's that expansiveness of space. It's the vacuum, the 0-point vacuum of space. There's more and more of it. While we're on that topic, we're going to jump, we're already here, to number 5. Reason for the accelerating universe. In SIG theory, what we have is this universe creating space, and this one, and this one, and this is getting bigger, and this is getting bigger, and this is getting bigger. So there's an analogy in the book that says if you have say 25 people in a room, picture 25 of these, each blowing up a balloon. That one's going to get bigger, this one, this one, this one, this one. They're all blowing up a balloon. Anywhere you are in that room, we're going to discount the edge of the universe, or the edge of the room. Any balloon that you're looking at is going to see an acceleration from everywhere else. That's CIG's explanation of the accelerating universe. Because each of these galaxies are creating their own space. They're losing energy. You have very energetic entities out there. And that's what's creating the space. It explains redshift anomalies. Now, when I first wrote the book, or the material I took to incorporate into the book, I was not aware of redshift anomalies. Now, a redshift anomaly is a manifestation of a gentleman who used to work under Edwin Hubble of the Hubble telescope fame. And what he found, looking through his telescope, he's looking through his telescope, he's here, he's seeing in the same planar region of space, he's seeing a galaxy here with a redshift of, say, x. He's seeing a little tail coming off here. He's seeing a quasar with a much larger redshift, say 20x. I apologize, I don't even know the units for redshift, but I know this concept. Now, this contradicts the Big Bang, so they took him off the telescope and said, you can't be right. This quasar is way out in outer space up here because it has a redshift of 20x, and your galaxy has a redshift only of x. So your quasar must be much further away, because if it were here in the same planar region of space, it would violate the Big Bang. And certainly they didn't want that, so they took him off the telescope. So CIG theory says any given stellar object, or even an atom, or anything that moves, is creating its own space, its own redshift, with the quasar having a redshift much greater than its galaxy, which since then it's agreed that yes, that quasar is attached to that galaxy. Well, if it is, then the Big Bang's wrong, and something else has to replace it. Now, this quasar in CIG theory has its own redshift, and the redshift is consistent with MTS. And the greater t, or the velocity with a limitation of c, the greater that, the very high intensity of a quasar has a greater redshift. So I'm agreeing with Holt and Arp here. And I think the rest of the community has finally caught on as well. And that solves, what does that solve? Redshift anomalies. That solves redshift anomalies. CIG, and I think I mentioned it before, it is consistent with redshift and the Doppler effect. What do we have here? We had the horizon problem. The horizon problem. Now, the horizon problem says, and I don't know how they take these temperatures, I don't quite know what they're doing, but if you have the universe, and you had a Big Bang starting right here, and you had the speed of light going this way, and you had the speed of light going this way and in every other direction, well, this represents C, and this represents C. But nothing travels faster than C. Nothing travels faster than C. So if you have a cup of coffee, right, hot coffee, eventually, if you pour in some cold cream, eventually all of this will come to thermal equilibrium. Now what they're doing is they're finding thermal equilibrium here, the same temperature as here, 2.73 Kelvin, maybe. I'm going by memory, maybe not. But there's a problem with this. The problem is that there's not enough time for this side to have mixed with this side to reach thermal equilibrium. The reason being is nothing travels faster than C. So this side could mix, and this side could mix, but this side could not mix with this side. But CIG theory looks at that and makes everything local. It localizes this space and says that at any time you're looking at temperatures, since you have stellar entities moving at, say, identical rates of travel, this equation says this side can create that temperature independent and localized from this side over here. So that's my solution for the horizon problem. That this side didn't have to talk to this side. Okay, a big takeaway is after knowing this theory, you go outside at night and each star is its own bang. You're now looking at a very active night sky where it's not just stars in the night sky, but the stars create the night sky. How do they do it? By the unfolding of the stars into space. And conversely, black holes space back into matter. Another notation is that RT, here's one equation I can deal with, but I'm saying that RT does not equal to D, or rate times time does not equal to distance. In a very classical slow world, yes, rate times time is equal to distance. But realistically, per CIG theory, you have an object going at a certain rate. Let's say 1 mile per hour for 2 hours, it's going to be 2 miles. But CIG says just the fact that this is moving adds a little more space, a little more distance than the classical equation rate times time. So I'm going on record that rate times time does not equal to distance per the CIG theory. Now when I say the classical world, I mean slow-moving objects. And the quantum world is anything, the slowest amount of movement possible over no movement. That equals the quantum world. So if you've looked at part 1 and now you have part 2, hopefully now you can tie in the 2 worlds of the very, very large and the very, very small. And I did have here number 13 with a question mark. So I'm going to leave the best for last. Although I think your new night sky, where each star is its own big bang, actually each atom, anything that moves is its own big bang. But if you look at the stars at night, you have a newfound appreciation, if you believe in the theory, that the space between the stars has come from the stars. So after hundreds of thousands of years of looking at the night sky, at least I'm seeing it in a different way than when I was little, where I saw the specks of stars in a black night sky. I'm now seeing that the specks of stars are created or are creating the night sky. So we are going to come up to number 13, which is everyone's favorite. And I'm not too good at drawing, but I am going to draw a flying saucer. Now there is a patent on the flying saucer, and if you haven't read it, you should. It was granted to the US Navy to a gentleman by the name of Salvatore Pais. This is the name P-A-I-S, in case you're interested, Salvatore. And in the Navy's name, he has the patent. And the patent, when I read it, that's a pretty bad flying saucer. But the patent, when I read it, to me made perfect sense in the context of CIG theory. Because what it did is it took an internal cavity and it had a microwave where they're now vibrating this cavity with a very high intensity on this craft. They call it a mass reduction craft. And then there's another lateral microwave. I believe it was in the microwave. It was one of the elements of the electromagnetic spectrum. And what do we see when we see, or I don't see them, I haven't seen them, someone has seen them, and they always say there's a glow and radiation around flying saucers. Radiation on the ground, glow up here where they're flying, and that's just the glow you'd get from a microwave here. Now we know when airplanes fly, we know over this wing, over the top wing, if we're looking at the wing, the velocity here is a little higher than the velocity here, the Bernoulli effect. And that greater velocity creates a lower density here, and that lower density creates the lift of the airplane because it's moving quicker here, a higher velocity. So per the Bernoulli effect, the airplane, multi-ton airplanes flying up there, and they're not falling out of the sky. And they work off of the principle of this density, a much higher density. If you have a disk now, and you can create a different space-time curvature with a lower density around that craft, you now have a viable flying saucer. What you can do is manipulate that curvature, vibrating this at a very, very high frequency, creating a circumference around the craft with a very low density space-time curvature, and like a ping pong ball might get sucked into a vacuum, the flying saucer gets sucked into its new environment. And you can manipulate that environment by only having that vacuum in the direction you want to go. And to me, that's done by the horizontal microwave in the patent. So I would recommend reading the patent by Salvatore Pais. It's very interesting. I believe it ties in with the new physics of CIG theory. Right now, flying saucers, they say they don't have any wings or means of propulsion or anything. The propulsion is the manipulation of their circumferential space-time curvature where the craft gets sucked into it. So I guess I'm at heart a conspiracy theorist, so I had to delve into that. And when I read the patent, I sort of backed into CIG theory like I try to back everything into CIG theory. So that's my theory. I have become space. I hope you've enjoyed it. This book, great for children, maybe 9 to 14. You might want to read it yourself. Thank you very much. I hope you've enjoyed the presentation.